does Pluto have an amazing secret? The fact that a celestial body no longer has official planet status does not mean that it has vanished from the center of astronomical interest. On the contrary, NASA's New Horizons probe has been closely examining the bitterly cold dwarf world and has discovered something amazing. Since then, there has been mounting evidence that life may exist on Pluto. The world of mnemonics also appears to be subject to the principle that nothing is made to last forever. As is well known, the phrase, "My father explains our 9 planets," to me, every Sunday, has long since become obsolete as a mnemonic for the order of the planets. On August 24, 2006, the number of members of our planetary system was reduced from 9 to 8 because Pluto was taken off that list. However, the reason behind the reclassification of the small celestial body is fairly straightforward. Experts had detected more and more Pluto-like objects in the remote Kuiper belt, and to prevent the list of our planets from bursting at the seams in the future, the International Astronomical Union decided to redefine the term planet, and for a celestial body to be considered as such, it must orbit the Sun, have an approximately spherical shape, and have cleared its orbit of other objects through its gravitational field. Ultimately, it was the last criterion that sealed Pluto's planetary fate, which is why it has since been listed in the newly established class of dwarf planets, and there is no question that Pluto has truly earned the addition dwarf with a diameter of just 2,376 kilometers. It's in fact more than 1,000 kilometers smaller than the Earth's moon in terms of cold. However, the dwarf planet has no need to hide from the other members of the solar system on its surface. The average temperature is a frosty 233 degrees C. That's only 40 degrees above absolute zero. Due to this icy starting point, it seems that Pluto is far too cold for all life forms known to us. Or does it? Well, not necessarily, but more on that in a moment. First, we should consider why the thermometer on Pluto falls so extremely far below freezing point. This is simply due to the immense distance between the frozen dwarf and the Sun. While the mean distance between Earth and Sun is still around 150 million kilometers, Pluto takes an incredible 248 years instead of 365 days to complete a full circle around the Sun, since it orbits our central star at a vast distance of 6 billion kilometers. How New Horizons exposed Pluto's true nature in terms of the celestial body's composition. While nitrogen ice predominates on Pluto's surface, the planet's atmosphere is composed of 99% nitrogen. The massive core, which makes up around 70% of Pluto's diameter, is primarily made of rock and is encircled by a mantle of water ice. Despite its small size, the dwarf planet is by no means traveling alone through space. It is accompanied by at least 5 moons, the largest of which is Charon, a naturally occurring satellite that is half as large as Pluto itself. For this reason, some experts think it makes more sense to think of the celestial bodies as a Pluto-Charon double system, rather than as separate entities. It's possible that the double system was formed by an astronomical kiss, as opposed to the long-held belief that Pluto and Charon collided catastrophically. More recent models propose a scenario known as kiss and capture, in which the two heavenly bodies collided but mostly survived. Thankfully, the NASA probe New Horizons, which became the first spacecraft to ever fly past Pluto's furthest reaches on July 14, 2015, more than 85 years after it was first discovered, also survived intact. When New Horizons plunged into the vastness of the cosmos on January 19, 2006, the 480 kilos probe took more than 9 years to bridge the enormous distance between Earth and the dwarf planet, and Pluto was still officially listed as a planet. Although the spacecraft has long since left the celestial body again and will pass the boundary into interstellar space in the best Voyager manner in less than 20 years. The evaluation of the Pluto data is still ongoing, but the information evaluated thus far has already revealed things that have left the terrestrial researchers speechless. For instance, the experts have discovered that Pluto's face is much more dynamic and varied than previously believed. After all, the landscape is not only dominated by cliffs of nitrogen ice reminiscent of the rugged coasts of Scandinavia, but also by gigantic methane ice blocks, some of which are as tall as skyscrapers. But that's not all. Pluto also has dormant ice volcanoes that dwarf even Mount Everest, as well as canyons that plunge even further than the Grand Canyon with regard to the 500-meter high. Norris, on the southern edge of the Sputnik Plain, experts assume that the mountain range consists of water ice, because under the bitterly cold conditions, this is as hard as stone nitrogen ice would simply not be stable enough to form such massive structures. But apart from that, we still have no idea how these special Pluto mountains were formed. At all, this is for the simple but crucial reason that there is simply no more massive celestial body in the realms of Pluto that could deform the crust to such an extreme degree, Pluto as a habitable world. When New Horizons arrived at Pluto, it reached a breakneck speed of 52 km/h. The probe was traveling so fast that it only got to see one side of the celestial body up close. Specifically, it was the hemisphere that was bathed in light of the distant sun, at the time the opposite side of the dwarf planet on the other. Hand was literally in the dark and could only be explored by New Horizons in the days before the closest approach and after the experts initially mainly evaluated the close-up images of the hemisphere. Pluto's shadow side has now come into astronomical focus. However, the corresponding images are not nearly as sharp as those of the other sides. Only landscape formations with a resolution of 2 to 30 kilometers can be recognized here, but what at first sounds rather rough is in fact 250 times more precise than the insights that the Hubble Space Telescope once provided us into the remote ice world. Accordingly, the New Horizons images show us Pluto's composition in unprecedented detail, and they even suggest the groundbreaking conclusion that the bitterly cold celestial body could ultimately be hospitable to life. After all, in fact, experts have long suspected that the dwarf planet is hiding a soaking secret because it could hide a huge underground reservoir of liquid water, and as we all know, water in a permanently liquid form is one of the basic requirements for the development of life similar to that on Earth. But how can it be that the cool liquid on Pluto remains liquid when average temperatures of 233 degrees C prevail there? Well, there are a few factors that can reduce the melting point of water, most notably salts dissolved in water and high pressure. But friction caused by tidal forces, which converts some of the kinetic energy into thermal energy, also prevents the water from freezing into ice. But what does this mean? In concrete terms, did New Horizons literally plunge into the depths of Pluto to explore the alien water world up close? Well, not quite, because the theory of the subglacial ocean is mainly based on the study of a region known as chaotic terrain. To the experts, it is a jumble of mountain ridges, gorges, and plains which faces Sputnik Planitia, and to understand how this confusing area was formed, Aidan Denton of Purdue University in the U.S. state of Indiana simulated how the shock waves triggered by an asteroid impact would behave in the case of Pluto in principle. The researchers assumed that the seismic waves would erase around the affected celestial body after an impact with the quakes colliding on the opposite horizon. There, they break open the surface and create very peculiar structures that do not easily fit into the usual landscape, and lo and behold, even Pluto's chaotic terrain could have been created by an asteroid impact. However, there is still a small caveat to this finding. For the simulation to work, the dwarf planet needs a 150-kilometer thick ocean below ground. Pretty exciting, isn't it? And yet it should be noted at this point that while it is a plausible hypothesis, at the end of the day, it's purely theoretical. In this regard, the skeptical researchers point out that the resolution of the New Horizons images is simply too low to be able to evaluate the terrain. With conclusive certainty, further research missions are therefore essential to find out whether there really is a potentially life-friendly ocean beneath Pluto's surface. how life on Pluto could unfold if the hidden ocean really exists, and even has inhabitants. The experts agree that it would by no means be a highly developed underwater civilization, but rather simple microorganisms. This is supported by the water traces on the nearby hemisphere, which have left a reddish, shimmering discoloration. The said discoloration in turn represents nothing less than an indication of a high concentration of organic molecules, and thus the prerequisite for life. It is conceivable that their origin lies in cosmic radiation or solar wind. After all experiments have shown that such complex reddish compounds can arise when molecules such as water, methane, or nitrogen are exposed to radiation bombardment, and if ammonia is also involved, the bases that we also find in RNA and DNA can even be formed. The paper by a group headed by New Horizons researcher Dale Cruikshank, which was published in the journal Astrobiology, is especially intriguing in this respect. It cites evidence that suggests Pluto's ice is not only red, but also contains ammonia in the same sentence. But the authors stress that this is by no means evidence that the dwarf planet also supports extraterrestrial life. The findings simply demonstrate that the small organisms might live there. What is certain, though, is that the red band crosses Pluto's equator, placing it in the region with the warmest climate and the most sunlight. In other words, 2 of the 3 requirements on the potential life checklist have already been met on the dwarf planet. There are signs of liquid water and data indicating the presence of organic matter. What is still lacking is a suitable energy source that keeps the conditions conducive to life. We can wait to see if and when Pluto will also reveal this final secret. If you're wondering if there is a cost to subscribe to our channel, we can assure you that there isn't. We hope to see you soon.